Hey everyone, Chang here and welcome to my channel. Today we're going to talk about decimals and fractions. Now, with a fraction like this, of course, it's very easy to figure out the decimal. What you're going to do is you're going to get 1 and you're going to divide it by 3. So you're going to have 3 out here and then you have 1. Can't go in there. You point the 0, then you point the 0, then you go there. It goes into basically 10 3 times and so on and so forth. No, I'm just kidding. We're not focusing on that. I actually have a video on that. So in case you guys are confused or want to refer to it, I'm going to put a link in the description down below. And also if I tag it, I think it appears somewhere on the video. I think it's this corner or that corner, whatever. I will have it linked somehow. All right, anyways, we all know how to change a fraction into a decimal. That is extremely simple. But the vice versa, the reverse of it, actually is a little more daunting. Now, if it's a finite decimal, fairly simple. You just put it under either the hundreds, thousands, tens, so on and so forth, right? And then afterwards, you can simplify it all you want. Well, when we're talking about repeating decimals, that's when it gets a little tricky. Non-repeating decimals, we don't have to worry about because non-repeating decimals, hopefully you guys will realize, is irrational. There's no way to write it as a fraction anyway. So our focus today is on repeating decimals. Now, hopefully from experience, if you guys didn't realize already, 1 over 3 is 0.3 with a bar on top. Basically, it's just 0.3 and 3, 3, and 3, and 3, and so on and so forth until, you grow old and die. Basically, it never stops. Now, that's easy. How would we know, ignoring from experience, from previous history, whatsoever, if we're given this and we're asked to write it as a fraction, what do? Well, actually, the interesting thing is there is this sort of technique or procedure on how we can actually solve it. First and foremost, let's just assume x equals 0.3 bar, right? This is going to be our fraction, what we're looking for. Well, this is the same as 0.333 and so on and so forth. Now, the technique, the trick, the procedure, whatever you want to call it, is the idea that where it is repeating, where that bar is, you take however many place it is and you multiply x by that. In this case, this is the 10th place, right? It starts repeating at the 10th place. So at 3, what we're going to do is we're going to multiply both sides by 10. And now, bear with me, it seems kind of weird, but first and foremost, if I multiply both sides by 10, right? I do 10 and 10, well, times and times, right? So we get 10x equals, and instead of 0.3333 on and on, right, the decimal actually moves one place over. So you actually get 3.333 and on. Okay, now, why does it matter? It actually uses an interesting trick. So we have 10x equals 3.3333 on. We don't like the fact that it goes on forever, right? That's what's throwing us off. So what we're going to do is we're going to get the original x and we're going to subtract it from 10x. So when we subtract x on this side, what that means is I'm subtracting 0.333 and so on. Okay, well, if I were to do that, what happens? Well, 10x minus x is just 9x. This is where the magic comes in, right? You have 3.3 so on, and you have minus 0.3 so on. So all those 3 that goes on forever after the decimal place basically cancels each other out. So what you have left over is actually 9x equals 3. Well, in this case, since it's 9x equals 3, if we divide both sides by 9, right, the 9 cancels. So we have x equals 3 over 9, or if we simplify it, x equals 1/3. And there it is. This is what we're looking for, right? The fraction in what this decimal represents, 1/3. All right, so let's look at another one, more complicated, right? 1/3 was way too easy. Why are we going to waste our time with that? Let's look at something like this. Now, this one, first and foremost, is not just a regular decimal. There's actually a whole number in front of it. But actually, it doesn't change the procedure all that much. It's still the same. The other one is that this is a weird repeating one. It's not just a simple one number and it repeats forever. This actually has a specific pattern, right? You have 1.2345 and the bar goes on top of all of these guys. So basically what this is is 1.2345, and wherever the bar is, it's just going to continue repeating. 2, 3, 4, 5, 2, 3, 4, 5, blah, 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 blah. Okay, cool. So, what do we do? Well, in this case, we're not just multiplying both sides by 10. Remember, first and foremost, we're trying to find some fraction that we can write this guy as, right? Well, if we multiply both sides by 10, it doesn't actually accomplish our goal. Remember, in the previous example, the overarching goal is that we got rid of all that repeating decimal, right? The multiplying by 10 accomplished it in the previous problem. This one, we actually have to multiply by some other number. Well, this is how we know, right? Imagine here, this is a tenth, hundredth, thousandth, 10,000. That's one way to go about it. Or, if it makes your life a little easier, just count how many times. 1, 2, 3, 4. So 1 and 4 zeros after it. So that's what we're going to do. We're going to multiply both sides by 1 and 4 zeros after it. In this case, it's going to be 1, 0, 0, 0, 0. That's 10,000, right? And you can either understand it through the decimal placement, or you can, well, count zeros. 1, 0, 0, 0, 0. You multiply it. That's probably not the best. Let's do little x's, just to make it less confusing. All right, cool. You multiply both sides. So what happens when you multiply both sides by 10,000? Well, in this case, you have 10,000 x, just to make it more clear, let's just put the little comma there. And this one is a little weird, but not really, right? You have 1, 2, 3, 4, 5. And think about it this way. You're moving the decimal place 4 times. 1, 2, 3, 4. So all of a sudden, these guys are all in the back, right? So it's going to be 1, 2, 3, 4, 5 decimal place, then 2, 3, 4, 5, 2, 3, 4, 5, and on and on and on and on. Okay? Well, when we subtract by x, that means we're subtracting 1.2345 on and on. So it's going to be 1.2345, 2, 3, 4, 5, on and on. Okay? So notice that. That's what I really want you guys to focus on, right? This whole idea of counting zeros or figuring out the decimal place and then multiplying both sides by that kind of number is this idea that once you subtract it, all of these decimal places are in line, and since you're subtracting, all cancel out. So once we subtract it, well, this one's going to be a not great number, but still is easy. 9,999x equals, and luckily these guys all disappear. Now you just have 1, 2, 3, 4, 5 minus 1. That's just 1, 2, 3, 4, 4, right? Basically 12,344. And afterwards, in order to find the actual fraction, you divide by 9,999 on both sides. And guess what? That is your fraction right there. And afterwards, some fractions you can basically simplify to a more lovely form, but if they don't require you to in any way, shape, or form, there it is. That is your fraction that would produce 1.2345, and then the repeating decimals is 2345. All right, so now we went over a simple one. We went over a fairly complicated one, maybe not super complicated. Let's go over a simple one again. Actually, this is like one of the best ones. I really like it because it actually shows something that to us intuitively is a little weird, but mathematically, logically, it makes sense. Now, you have 0.9 with the bar on top, and at this point we should be comfortable that this is just 0.999 on and on and on and on. Okay, cool. Let's write this as a fraction. Well, here's what we're going to do. It's on the 10th place, or basically there's only one, right? So it's going to be 1 and 1, 0. So you're going to multiply both sides by 10. So what you have is you have 10x equals 9.9 on and on. Cool. And we also know that x is basically 0.9 on and on. And if we want to subtract both sides by x, just to get rid of the repeating 9s at the end. So what do we have? Well, 10x minus x is just 9x. 9.99999 on and on, subtract 0.99999 on and on, right, equals 9. If you guys aren't freaking out yet, let's just continue. Divide by 9 on both sides. This 9 cancels, and that 9 technically cancels as well. You have x equals 1. So that means to write 0.9, repeating forever, as a fraction is just 9 over 9, or just 1. Meaning that this right here is just the number 1. Now, the first time I saw this, it was just mind-blowing. It made no sense, right? Intuitively, we want to say if it's 9 going on forever, there's always that forever 0.0000, and maybe eventually that little 1 that would make it hit the whole number 1, but that's actually not the case, right? For a decimal, for it to be 9 going on forever, actually, it is the same as that single whole number. So you guys can sort of guess, it's not just with 0.9. If I did 4.9 bar, right, or 99.9 bar, by that same logic, and I want you guys to verify for yourself, try it out, right? By that same logic, this is technically just 5. This is just technically 100. And that's amazing. Weird, non-intuitive at all, but freaking amazing. That's what I love about this more than anything. All right, so there you have it. We're at the end of the video. Now, this is an interesting topic, for me at least, because I feel like we've always focused, every time we're learning fractions and decimal, how to convert fractions into decimal, because it's easy. All you have to do is divide. Rarely, if ever, we will learn about how to convert decimal into fraction. Now, for the finite one, yes, we can do that. But for the repeating one, I feel like, from my experience, it's always just super glossed over. Here's the technique a little bit, and then that is it. You maybe get a day or two of it, and then you're expected to either know it or whatsoever. Why is it important? Why it works? No one really says, right? Now, remember that the goal of it, the goal is to eliminate the repeating decimals. So it's not always going to be multiplying 10 by both sides, or 100, or 1,000, or 10,000, right? You have to see where the repeating decimal sort of, I guess you could say, starts its cycle. In this case, it's only 1, right? It just keeps going, and then there was the other one where it's actually after 4 numbers. Some of them is going to be after 9 numbers, so on and so forth. So you got to be careful of that. But after you know it, this technique, this method, procedure, works just the same. Multiply both sides and subtract, and the goal, you get rid of all the repeating one, and then you have something to work with. Now you can find the actual fraction. The other one, I'm hoping that you guys got out of this video, is the fact that whole numbers are basically whatever the whole number is with .9 and repeating forever, which is pretty cool, right? Thank you for watching this video. Hopefully you find it helpful. Please like, comment, and subscribe. I will see you in the next video.